in the past, I would ask you to find out the highest common factor of two numbers. So, for example, what is the highest common factor of, let's say, 870, 926? I would ask you something like this. Find out the highest common factor of two numbers. Well, it doesn't always have to be two numbers. You could find the highest common factor of three numbers, or maybe four numbers, or whatever. But in this video, I'm gonna show you how to find out the highest common factor of these three numbers. You could look at it and see, oh, there's a 5 here, 5 here, 5 here, and you could say yes, 5 is a factor of all of 5 is a factor and it's common to all these. But it's not the highest common factor. It is just a common factor. 5 is a common factor of this, this, and this, but it's not the highest common factor. So to answer this question here, break these three numbers up as product of primes. So try to remember as many primes as you can. Once you've got it, well, let me show it to you anyway. Let's try and break this down as product of primes. So this we could imagine it as well, I can see it's divisible by 5 here. So let's try 5. So does this number here divide 5? So let's jump to a calculator. Hang on. So 2695 divided by 5. It should be able to divide by 5. Yes. 539. Okay. For some reason, when I see a 9, I think I will try a 3. I think it may be able to divide by 3. If it doesn't, then maybe jump to 7. Try see if it divides 11 or whatever, and move up each time it fails. So well, let's try and see if we can divide this by 3. So calculator, let's try and divide it by 3 and see if it gives us a whole number. It doesn't. So 3 is not a good it's not a good one. Let's try 7 divided by 7. Okay, yep, it works. 7 works. So hang on, let me get rid of this. We didn't try 3, we tried 7. So you can visualize this as 7 times 77. Okay, and then you can see that 77 is 7 times 11. So here we've just expressed this number as product of primes. This is a prime, this is a prime, a prime, a prime. So we've done this one. Now let's try it with this one. I'm going to run out of space, so I'm going to jump over here for a bit. So hang on, 9075. So let's try and break this up. Well, 7. Well, there's a 5 here, so let's try 5. So it should be able to divide by 5. Wait there. Let's try it out. Clear this. 9075 divided by 5. We should get a whole number, yeah. So it's 1815. Well, I'm going to try 5 again because there's a 5 here. So let's try 5 again. So it should divide 5 as well. Let's divide it by 5. Divided by 5. So that's 363. Well, when there's a 3 there, I'm going to try a 3. Let's see if this divides 3. Hang on. It should do. Okay. 2 1. What was that? 1 2 1. Sorry. Hang on. So should be 1 2 1. Okay, and this number should be familiar to us. It's 11 times 11, because well, to me, I recognize this number as being in one of the tables, times tables. Okay, so now we've just broken this number here up as a product of primes. Okay, one prime, another prime, another prime, another prime. Okay, so now let's try and break this up. So that's hang on. Let me move it down here. So it's 1 1 1 4 7 5. I think. Let me double check. 1 1 1 4 7. Yeah, that's right. So let's try and break this down. Again, because of this 5 here, I'm going to try 5. 5. Hang on, calculator. Clear it. 1 1 1 4 7 5 divided by 5 equals 2 hang on 2 2 2 9 5. Because of this 5 here, I'm going to try and see if it divides 5 again. I'm going to try 5 again. So let's divide it by 5 equals 4 4 5 9 4 4 5 9. Because well, I'm going to try a 3. Let's see if it divides 3. Hang on, let's see if it divides 3. So divides 3. If it doesn't, then jump to the next prime. Well, try 7. No, it doesn't. So let's try 7. 4 4 5 9. I'm not going to try 5 because well, it ends in a 9. So let's try 7 divided by 7 equals, yep, 7 works. So so 7 here, 6 3 7. Okay, let's try see if that divides 7. Hang on, divide 7 equals 91. Yep. So this number here works. 7 91. Does 91 ring a bell? 9. Hang on. Let's see. Let's hang on. Let's try divide by 7. Does that work? Yep, it works. 7 here. Well, we can visualize. Sorry, did I say something? We can visualize 91 as 7 times 13. Okay. So now we've broken up this this number here as product of primes. Okay, all these are primes. So now let's try and write everything down here. So let's look at 26 95. Where that? So we can see 26 95. Well, if we were to write this as a product of primes, it would look like this. 5 7 7 11. Hang on. 5 times 7 times, is that 5 times 7 times 7 times 7 times times 11. Okay, and let's try and do this one now. 90 75 90 90 75 equals what equals what? Equals these here. 5 5 3. Well, let's try and keep it in order. So 3 5 5. Let me double check. So it was 3 5 5 and then 11 and 11. Okay. So this would be like this. And then the last one's quite long. This one, hang on, it was 111,475. Well, that equals, hang on, that equals 5 times 5. Okay, so that equals, well, this equals 5 times 5. So 5 times 5 here, times 7 times 7 times 7, and then the 13. Okay, so 3 sevens. Hang on. So 7 times 7 times 7, and then you've got the 13 at the end. Okay, and by the way, if you were to write this properly, this would look like this. If you were to write 2695 as a product of primes. You should write it like this: 5, and then merge the two 7s together. 7 times 7, well, write it as this, okay, times 11. And this one here, you could write it as 3 times 5 squared times 11 squared. If you were to do this properly, I'm just doing these squares here to make it pretty, that's all. And it's easier to see what's going on. And here you would write this as, but if you were to do this in a test, you would probably have to do this: times 7 squared, so 7 to the power 3, because you got to get 7 times 7 times 7, and then times it by 13 again. Okay. Well, anyway, so you can break up or you can break up these three numbers as primes here, product of primes. Now, if you want to answer the question, what is the highest common factor? Well, let's see what they've got in common. Well, when you say common, it has to be in common with all three. Okay, so you've got to look for something that's in common with all three. Now, let's look at the first one. This one here. Well, there's no 3 in the first one. So though there's a 3 in the second one, this one here, there's no 3 here, and there's no 3 at the bottom here. So 3 is not in common with all three. It's just in common with itself, if that makes sense. Well, anyway, if you look at the 5 here, this 5 is in common with all three. Okay, so 5 is in common. Well, here, even though you've got another 5 here, well, there's only one 5. We can't use another 5. So if you look at the first one here, yes, you've got a 5 here and a 5 here, but that's just in common with these with the bottom two. It's not in common with all three. So we can't use another 5. We can only use one 5 here, even though you've got a surplus 5 here and a surplus 5 here. There's not another 5 up here, so you can't use a 5. Okay, let's have a look at 7 here. 7. Well, you've got lots of 7s down here, plenty. But in them for the middle one, there's no 7, so you can't use 7. Okay, and then 11. Well, 11 here is, you've got an 11 here and an 11 here, but then you don't have an 11 at the bottom. So the only thing that's in common with all three is 5. So the actual highest common factor of so hang on. So the highest common factor of 2695, 9075, 114, another one there, 75 equals, well, the highest common factor is just 5, because 5 is what's in common with all. Well, 5 is a factor that's in common with all three, and it happens to be the highest, even though it's quite low. But so suppose here, if you have let's say you've got 11 here, you've got 11 here. You don't need this one, but let's just imagine that there's another block of 11 in this one here. Okay, so in which case you would say, oh, 11 is also in common here. Okay, and remember, we are just imagining we were just imagining there's an extra block of 11 here. Then in which case you could say 5 is a common factor, 11 is also a common factor. But the thing is, if we merge these two together, then 55 would be the highest common factor. Okay, this is assuming that we are just pretending there's an extra 11 over here. Okay, well. Anyway, the highest common factor here is actually 5, even though it's quite low. Okay?